All right, in this next video, we're going to go over two examples with rate conversions, specifically ones where we need to consider rates for an IV pump, and we're going to consider the strength of the IV bag. Both of these examples will include new units, things that we haven't seen thus far this semester. So previously, when we were doing oral dosage calculations, parenteral dosage, weight-based dosage, the order was 50 milligrams or 50 milligrams per kilogram, or 250 milligrams. The order was very clear. It was one value or a weight-based value, and we needed to calculate how much to prepare. We are now moving into situations where the order will be a rate. So in our first problem here, we need to make sure our patient receives potassium chloride at a continuous rate of 4 milliequivalents every hour. This is the IV bag that we are going to hang. And we need to make sure when we are setting our IV pump that we set the correct milliliter per hour rate for this bag for this rate. Lots of arrows. So what should we do? Well, similar to previous calculations, we can start with our order. What needs to happen is our patient needs to be given a certain number of milliequivalents per hour. When I'm done with my calculation, I need to know the equivalent rate in mLs per hour. You might remember this. This is us making a plan. I need to get from milliequivalents per hour into milliliters per hour. I already have hours, so I'm going to circle that. There's no time conversion needed. If I look at my numerators, I have to get from milliequivalents to milliliters. That is not a conversion to memorize. That is coming from our bag. So this right here, too many arrows. Let me get rid of some of these. There we go. So the strength of the IV bag that we are hanging, there are 20 milliequivalents in this bag of 1,000 milliliters. That needs to be used in this problem. That is the conversion that we need to use to go from milliequivalents to milliliters. So I'm going to do my dimensional analysis. I'm going to start with what I want to change. 4 milliequivalents in 1 hour. I am multiplying by a conversion factor, specifically the one where I can turn those milliequivalents into milliliters. The milliequivalents will cancel. I will be left with milliliters per hour, which is exactly what I want. There are 1,000 mLs in this bag and 10 milliequivalents. When I multiply the numerators, I get 4,000. I divide that by 20. I should get 200 milliliters per hour. So if we need our patient to receive 4 milliequivalents per hour and we are hanging the IV bag that is provided to us, well, there are 20 milliequivalents in this bag of 1,000 mLs. We can use that as our conversion factor. 4 milliequivalents converts to 200 milliliters per hour. Next problem is a little bit of a review. So if you want to pause the video and try it yourself, please do. We're told that this infusion started at 13:20, which is 1:20 p.m. And we want to know how long is it going to be and how long it'll be till the infusion's done and what time will it be. So what's the completion time? We have a 1,000 ml bag that is infusing at 200 mLs per hour. We can use our volume and our rate to calculate the time. Lots of ways that we can approach this. One way is to use dimensional analysis. If I know there are 200 mLs going in every 1 hour, I can use that as my conversion factor. I should get 5 hours. Or if I wanted to use a proportion, if I know there are 200 mLs per hour being infused, well, what's an equivalent ratio or rate if I have 1,000 mLs? How many hours is that? So I see here that my covariant factor, my scale factor is 5. We still get 5 hours. So that means if we have 5 hours later, from 13:20, if I add 5 hours, I would be at 18:20. So that is the completion time. We're going to go over one more example using a new unit, oxytocin. So there's one example here, but there's two parts. So oxytocin or pitocin stimulates uterine contractions. It's used to induce labor and to prevent postpartum hemorrhage. Now, this problem is hinting at a few topics that we're going to see later in the course, which is titration. What we're told is that the patient that we are working with, we need to make sure that we start their infusion so that they're getting 1 milliunit per minute. This information about increasing by 1 to 2 milliunits every 30 to 60 minutes until adequate contractions, that's definitely important. But we're going to focus just on the initial rate, initial starting value. In other words, I need to think about if I'm starting this infusion as 1 milliunit per minute, what am I going to set my IV pump to? In other words, what are we going to set our IV pump to in milliliters per hour in order for our patient to get 1 milliunit per minute? If you want to pause the video here, I'm going to make my plan, which is going to be crucial in these problems. And so milliunits need to be turned into mLs, minutes need to be turned into hours. That's a direct conversion. We need to use the bag in our conversion factor. So if you want to pause the video here and think through your plan, try the problem, please do. Moving forward, we need to use this strength. There are 20 units of pitocin or oxytocin in this bag, and this bag has 1,000 mLs. I have to use that. So that means if I can turn something into units, then I can turn those units into mLs using that bag. Well, milliunits to units is a conversion to memorize. Milli to the basic unit is a factor of 1,000 to 1. That's my plan. I'm going to follow that dimensional analysis plan. I'm going to turn 1 milliunit per 1 minute. I'm first going to turn those milliunits into units. And I know 1 unit is 1,000 milliunits. I am now going to turn those units into mLs using the strength of the bag. There are 1,000 mLs in the bag, and it has 20 units of medication. And then, so I have mLs. I want to turn those minutes into hours. I really want to stress the importance of thinking through your dimensional analysis before you start your work. That's the number one mistake that I see, is that students will jump right into the dimensional analysis. They'll start, they'll get halfway, and they forget where they're going or where they're going. It's because they've started too soon. Your plan should guide your dimensional analysis, using and thinking through all of the pieces that you're given. When we do our division, we should see 1,000s cancel, and I'm just going to have 60 divided by 20. So I multiply all the numerators, multiply all the denominators. We should get 3 mLs per hour needs to be given. Okay. This situation is the infusion rate that we would start. So we would start at 1 milliunit per minute. If we hang this bag, we set the pump for this rate, our patient's getting 1 milliunit every minute. We would want to assess to see if it's working, whether or not those contractions are adequate. I'm not sure how adequate is defined in this situation, but we would increase by 1 to 2 milliunits every minute, every 30 to 60 minutes. So we would assess our patient, see how it's going, and potentially make some incremental adjustments. This part of the process is called titrating. You're titrating the dose. You're increasing or adjusting the dose. We are told in the next problem that our patient, this should be up here, after a number of adjustments, a number of titrations, the pump is running at 33 mLs per hour. How many milliunits per minute is the client receiving? we are using the same bag that has 20 units per 1,000 mLs. We're using the same bag. Our plan is going to be the reverse direction. I'm starting with milliunits per minute. Whoops, I'm sorry. We're starting with mLs per hour on the pump. We need to turn 33 mLs per hour into an equivalent number of milliunits per minute. So I need to turn my mLs into milliunits. I need to turn my hours into minutes. The time conversion should be something we're comfortable with. The numerator, I can turn those mLs into units using the bag, and then I can use my understanding of the metric system to turn those units into milliunits. That's my plan. If you want to pause here, go ahead and do that. I'm going to move forward. I'm going to turn my mLs into units. There are 20 units in that bag. There's 1,000 mLs in that bag. If I stopped right now, I would have units per hour. Not quite what I want. I want to turn those units into milliunits. If I stopped right now, I would have milliunits per hour. That's what I want in my numerator. The last step is to turn those hours into minutes. I am going through my dimensional analysis, not guessing. I thought through all the conversions I wanted to do using the plan that I have up here. All right. So what we should find is that the product of the numerators divided by the product of the denominators, we should get, I believe, 11. Milliunits per minute. Let me double check. Yes. So this is the number of milliunits that they're receiving every minute. The key with these problems is we need to convert one rate into another, and we have to use the available strength, the available IV bag. It's similar to the calculations we've seen thus far this semester, in that we're using our conversions to memorize. We're converting one unit into another. What makes this a little bit different, we're working with a few different units that are new to us, milliunits, milliequivalents. The ways that they're presented to us are different. They're presented to us on an IV pump screen, or they're presented to us on an IV bag. One more video to go, just a few more examples.